Hello?
Hello,
Hello.
how are you tonight?
Good, and you?
Good, thank you.
So this is the question that I need help with.
No problems. Take a look here. All right, so area of the base of the prism, find the volume of the prism, find the surface area of the prism. Okay, so have you looked with, have you learned how to find the area of a hexagon?
I learned how to find the area. I'm basically doing a Pythagorean theorem.
Pythagorean theorem.
Yes. So basically what we're doing is splitting these hexagons into triangles and applying that Pythagorean theorem to find the area of the base.
Okay. So can you draw, do you want to sketch out, like when you look at that hexagon base, how many triangles are you finding?
6.
Okay, do you want to draw some lines for me so I can see where you're looking at?
Yep, so that's it. Those are the 6. And yeah, so what I'm having trouble with is the 6. I don't know if it's 6 centimeters or 14 centimeters.
So the 14 is actually showing us, the 14 would be a number we have to use to find the volume.
Okay.
That's kind of showing the 14 is, there's a pen here. The 14 is referring to the depth or the length or the height of the actual prism here. So this red line there, that's the 14 line. So the 6, now I'm just looking here. So if we look at the shape you just drew, we'd know that the side length of each, we know that one of the side lengths of the triangle is 6 centimeters, right, all the way around.
Yeah.
Now, how would you go about finding, like, so let's say I focused on this triangle here. How would you find the other 2 side lengths?
Okay, so I'm just gonna do it here again, if you don't mind.
Yeah, no problem.
So I'm gonna put that. I'm just gonna put that in half like this, and I notice that there's a right triangle there.
Okay.
So this whole thing is 6 centimeters, and this is approximately half of that. So I know that this is 3, and I know this is 6. Still with me, or you're kind of confused?
No, I'm understanding. Yeah.
Okay.
So using Pythagorean then.
Yeah, to
So
find
the 3 would be, let's say, A, and the 6 would be B, and then so we need inside C.
Okay, so what is A and what is B again?
I would likely call, I mean, it doesn't matter.
Yeah.
I would likely call the 3, the side that's 3, A.
Okay.
And the side that's 6 would be B.
Okay. $37, $38, $40, $42, $42. So you get 45.
Yeah.
You square that. I don't know what that is though.
Yeah. Now when you find the square root of 45, it's not 45 isn't a perfect square. It's going to leave you with a decimal. It's going to leave you with a decimal number as an answer.
Okay, so I'm just going to get a calculator to basically do that. Okay.
No worries. Yeah, it's going to be like 6.7.
Yeah, okay.
Like that.
Okay, so 6.7. Okay.
Don't quote me on that.
Oh no, I just calculated right now. It's 6.708. So I'll just do 6.7.
Yeah, so I was just kind of estimating, so I didn't have the exact value. So then that 6.7 would be your missing side length. Now I'm just trying to figure out base times height. I'm just trying to understand why they want. So your teacher said to use Pythagorean theorem?
Yeah.
Okay.
But what is the height in this equation? Doesn't give us.
Yeah, like I'm trying to so we've got that missing side length, which is 6.7 centimeters, but that side length isn't going to be necessary to find the area of the triangle, right? Like when you look there and you've got your 6, so you've got your 6 and your 3, right? Mm-hmm. The 6, so if we look at that as a so if we've taken that hexagon and we've broken that into 6 equal shapes, and all 6 of those shapes are the exact same triangle, correct?
Yeah. So
then if we do that, what formula do we use for the area of a triangle?
Base times height divided by 2.
Yeah. So base times height. So we've got base would be 6, height would be 6, right? Because before you said that half of the length of the, sorry, I'll just put a line here. We said that half of that triangle here was 3, right? Which means the entire thing would be 6. Mm-hmm. So if we've got 6, 6 times 6 is 36, divided by 2 is
so 18. We don't really need to use the Pythagorean theorem then?
To me, I don't know why you would need to use Pythagorean. Just because we've got, if you're finding the area of the base, there's no need to find the imaginary missing side length. Yeah. So I would do 6 times 6 is 36.
Yeah, I divided that by 2. Sorry, it looks like a 12, but I divided it by 2 and I got 16. So I multiplied that by 6, right?
Hang on a sec though. You did 6 times 6 is 32, but 6 times 6 is
32. Sorry. Yeah, my
bad.
It's
36 cut in half, which is 18.
Yeah, I made a mistake. Sorry.
No worries. I make mistakes all the time.
You okay?
Just fighting a cold. Sorry for the coughing.
Okay. Yeah, so you were right. It is 18. So I'm just going to take that 16 to an 18. Okay. So I do 18 times 6 to find the area of all of them.
18 times 6 would work. So you're, what are you, 108?
Okay, I'm just going to check the back of my textbook to see if that's right.
Okay.
What question was this for? It's saying it's 7.62 centimeters.
The area of the base is 7 point what?
7.62 centimeters.
That is not making any sense to me. Just think about it. Each side length is 6 centimeters, right? Mm-hmm. So if you've got the area inside of, you've got 6 side lengths at an area of 6 centimeters or length of 6 centimeters each. Mm-hmm. So I don't know how the area of all that space would be 7 decimal something.
I don't know either.
I'm just trying to think how else we can.
Yeah, I'm just trying to think too. Maybe there's something that I did wrong. Okay, so.
Yeah, it's a tough one, right? Because technically, because you're a grade, I think you're in a grade 8 room right now, right?
I'm in grade 8.
So typically, grade 8, we're looking more at we're looking